Okay, so in this question we have got a fish tank, and inside the tank we have got water. The height is 60 centimeter. Here we'll see the coordinate system. So this is kind of x, this is the z, and we can say this is the 0 0. That means that's the center of the coordinates x and z. The gravity, it is actually acting this way as usual. This is the water inside the tank, and we have got 2 points, point 1 and point 2. So here you can see the accelerations. It is actually working the upward and the downward directions. You just look the arrow here. So what we can say is, along the horizontal axis the acceleration is 0. So yeah, we'll only consider with the elevations. So this height is 60, I already mentioned. Now 3 cases. We need to determine the pressure. So you can see this is the liquid and we have 2 points. So the question is the pressure at the bottom of the tank. That means, let's say at the point A, when the elevator is stationary, so when it is at rest, when it is moving up with the acceleration 3 meter per second, and when it is moving down with the acceleration 3 meter per second. So that's the overall question. We actually need to pressure for this problem. So this question is a little bit different, but yeah, this is important. So we know the water density, it is 1000 kg per meter cube. So it's known. So we'll start the analysis. Here we need to calculate the pressure. So from the theories, we already know the pressure difference between 2 points. We already discussed it, so I'm not going to show you here again. We know, I'm writing the final term. It is the density and the acceleration x into x2 minus x1 minus rho g plus az and z2 minus z1. So that's the formula we already know. Right, so we can simplify this, or we can write it like this: P1 minus P2, it is equal rho G plus AZ into Z2 minus Z1. Here actually, what we did, this is actually the pressure difference between 2 points 1 and 2. So what we did here is we put this acceleration ax, it is equal 0, because we're not getting any accelerations along the x-axis. So if we put this term like this, so we can write it, then we can write it like this. Okay, now if we take the point 2, this is the free surface. If we say this is the free surface, okay, and point 1, this is actually the bottom of the tank. So we can say, as it is the free surface point 2, so it will be the atmospheric pressure, or the P2 equal P atm, as it is the free surface. And this is point 1, this is point 2. Let's say this is Z1, this is Z2. So we can say this, the difference Z2 minus Z1, this is actually this height, 60 centimeter. So that we can tell. So what we can write it down here is, we said P2 is the atmospheric pressure. So we actually need to calculate the pressure at the bottom. So we can say P1, or the pressure at the bottom, it is equal the density, gravity into Az over H. So this is, we said H. So yeah, we have got this formula here, and we took the point 2, this is the free surface, and point 1, it is the tank bottom. So we have the pressure at point 2, it is the atmospheric pressure. Okay, so now what we'll do is we'll actually calculate the 3 different cases here. The first case is when the elevator is stationary. So look, we are going to use this formula for all 3 cases for the pressure at the bottom point. So now when the first case, the case 1, okay, case 1, when it is stationary. The tank is stationary. What it means? Stationary means no accelerations. That means the AZ it is equal 0. So if AZ equal 0, then the pressure it will be rho g into H, isn't it? The pressure it will be rho g H at the bottom. So I'll just write it down here. The pressure at the bottom surface, it will be density gravity into the height. So density is 1000. This is kg per meter cube. Gravity is 9.8 meter per second square, and the height 60 centimeter, or you can say 0.6 meter. So we are going to calculate the pressure at kPa. So here we have the kg meter cube, so and it is meter per second square. So what we can write it down like we can write 1 kilonewton it is equal 1000 kg per kg meter per second square. So that's what we can write. And now if we solve this, the pressure it will be 5.89 kilonewton per meter square, or we can say it is 5.89 kPa, the conversion units. So this is the pressure at the bottom. So this is the first part of this problem. Now the second part is when the tank is moving up. Okay, when the tank is moving up. So moving up means it is the origin. This is the 0 point, the origin. When it is moving up, so it is going, the acceleration is along the z-axis. So the AZ this is equal 3, positive 3, plus 3. Okay, so then the gas pressure at the bottom, P, it is equal rho G plus AZ into H. Okay, so the density is now again 1000, gravity 9.8, AZ is 3, and this is 0.6. Again, what I did, I didn't write the units here. So the same thing, I will multiply, I'll convert the unit by using this conversion factor. 1 kilonewton equal 1000 kg per meter cube second square, meter second square. So it will be like 7.69 kilonewton per meter square, or you can say 7.69 kPa. Now the last part is when it is moving down. Okay, when the tank is moving down. So moving down means now it is going this way, and it is just the opposite of the z-axis. So we can say AZ this is equal -3 meter per second square. I believe you understand. Then the pressure P is rho G plus AZ into H. So this is 1000, 9.8 minus it is 3 into 0.6. Same thing when we will do this simple calculations, like we'll use 1 kilonewton equal 1000 kg meter per second square, then we'll get this value is 4.09 kilonewton per meter square, or we can say it is 4.09 kPa. So that's actually the pressure actually when the tank is moving down. So what we got here is, you can see this is when moving down 4.09, when moving up it is almost double. Yeah, so when moving up in an elevator it is almost double while it is moving down. So that means the tank is under much greater stress during upward accelerations. So that's the the findings that what we got when the tank is going up. The tank is under much greater stress during upward accelerations, and we're getting mass pressure. It is almost double. So this is how we need to solve these questions. So when it is moving up, the acceleration is positive. Moving down, acceleration is negative. So that's it.